Hey everyone, welcome back to the channel. Myself Devanshi Kesarwani, and let's solve the problem sliding window cost problem. This problem is quite similar to the sliding window median problem. It's better to watch that first and then try to solve this problem. So let's see what the problem demands. We are given with an array and window size k, and for each window we need to find the minimum total cost for making all that elements equal in that window. Sorry about that. So n is 8, k is 3. That means we have this array with us. So let's start with the first window. If this is our window 2, 4, 3, then I want to make them equal with the minimum cost. So let's try to make everyone 4, just random. So I have to add 2 over here and 1 over here. That means this is going to give us 3 total. 3 cost is required to make them all equal to 4. What if we have this window, or let's try to solve if we have any better solution for this 2, 4, 3. Let's try to make this time everyone 3. So if I have to add here 1 and I have to decrease it by -1, but the cost would be the absolute. So +1 plus -1, that is going to give us 2. So the cost is less indeed. So that means we found a better solution. Like this, so for this window we have 2. For this window, if I say 4, 3, 5, that means let's try to make them all 4. So +1 I have to put the energy, and I have to again do -1. So this is going to give us 2. So for this also window 2. So like this we can go ahead. Now if you look at this diagram clearly, there are 3 points. Let's say there are some points 10, 15, 20, any point. If I look at this point, then and I try to decide, I will make them all equal to white point. So I have to put this amount of energy for this and this amount of energy this. So these are like big differences, or vice versa. If I try to make this everyone as blue, then I have to put this amount of energy, and for this amount of energy. This is also quite big. But if you look the yellow point, if I try to make this one the yellow point over here, means that blue point I try to make it yellow, and this I try to make it over here, the white to also yellow, then this I think is kind of a minimum. That is kind of sweet spot, which is and this point is nothing but the median. So in a given numbers, if I try to make all equal to the median of the number of median, then that will be the minimum cost, and that's what the median efficiency, the middle value. So if everyone tries to be close to the middle value, then neither of them have to put a lot of energy, because in these scenarios all of them try to be over here, and rather the each point, if they have to go at the extremes, then that would be a lot of energy. This guy go to the extreme, these are a lot of energies which we have to put. So that's why the middle value will be the sweet spot. So now this is quite this last problem, which was the median we have to find. Let's revise this what we were doing to look at this window specifically. So we have 2, 4, 3 with us. We will have the 2, min half, max half. First we are going to put in the min half, because we are trying to say that pick one, the min half is the R median. Then 4 will come, which 2 is less than 4, then it is going to be put in the blue box, the max half. Then 3, 2 is less than 3, that means again it is going to put in the max half. But wait a second, the balance has been disturbed. We always want the pink one to have one extra value, considering the window size. Here the window size is 3, so it should have always one extra value considering the window size. So if window size is 3, the one side is 2 and the other side is 1, so it is more than half the window size, because the blue has more. So we are going to transfer this, the minimum value, from the blue half to the white half to balance. Now 3 is our median, and at this point of time, if you look, our graph is something like this. Here is 2, here is 3, and here is 4. This part is the pink section, and this part is the blue section. If I try to form an equation, say this carefully. If we have 4 with us, and we subtract the min half values, 2 plus 3. Now everyone is trying to be the mid value. So this 3 is coming again. That means I need to add plus 3. Why to add? Because we are subtracting, right? To 4 minus 2 minus 3. plus 3. So these guys are going to cancel and this is our 2. So that's the balance. If you see in the number line 2, 3, 4, plus 1 I have to travel, plus 1 I have to travel. The 3 doesn't have to travel anywhere. That means if we subtract 4 minus 2, which is 2, so they are going to have the difference value as 2. So this kind of becomes the equation to calculate. Now the code logic remains the same. We have to add, we have to balance, and we have to remove it. And if I took this example, so we have already calculated the, and this was the case. Now the window is going to move forward. That means now we have to look over this. So for this one, 435, we have to remove first this. So the remove logic will trigger and 2 will be removed from here. Then 5 needs to be added. So again we are going to look, 3 is less than 5. So 5 is going to go over here. So okay, this was 3, 4, 5. Now window size, it is crossing the half. So again we have to balance. So we will pick the minimum and we are going to put over here. So that means 4 will come over here. This is 3, this is 4. Again the equation. So and this will be removed. So max half minus min halves, 3 plus 4, and again the median, which is in this case is 4. So we need to add. So 5 minus 3 plus minus 4 plus 4, this is going to get cancelled and this is going to give us 2, the difference, right? So like this we are going to move forward, and now we will look at the coding and there things will be more clear. Okay, the similar logic which we have wrote, adding, removing, balancing, and the main function. So we get the input, then we insert, and we have one min half. For that pink one we added it, and then we started filling our first window. Then how we are filling, we took the median, thinking okay, this is our median, and then we said that if current median is less than value, then we are going to have it inserted in the max half, and then also we have to make the sum also. So some max we are doing at the same time. Now if max half size, because that means we have to do the balancing. So I will have a moving where I will say max half element, and we need to have the minimum. So begin is going to point the smallest element in this max half, and this has to go in the min half, right? So we are going to insert this moving, and then also some min half is going to increase. I hope you can picture that 2, 3, 4, 5, 1. So I will just add it over in the sum, simple. And then since we have removed it, so we have to remove it from the max half. So removing is simple, max half dot find and that moving element, and the sum from the max half have to be decreased. So that logic. And similarly we have when the value is when the current median is bigger, then we are going to simply add in the min half. So we are going to insert it, we are going to insert in the increase the sum also of the min half, and then if min half size has been increased a lot, then we have to again balance. So same logic, ll long moving equal to min half dot right begin, because here we are going to take the max, the big element, and then we are just simply going to insert it, max half dot insert the moving. And do note we have to decrease the min half and increase the max half as the new element has been added, and we are going to erase it. So min half dot find dot find moving, and then we have to take that min half and decrease the. So this is the simple logic. Again, now comes the removing part. So removing is simple. We have the we find that where it is the value is present, we erase it, and at the same time we have to decrease what, we have to decrease the sum also. So we are removing from max half, so sum of max half will be decreased value. Same goes for the min half. Some min half the value is going to be, and if min half is empty, that means we have to bring some value from the max half and we have to put it. So that logic I think we can copy. So we have to bring from the max half, right? So max half, yeah. So I think this logic will work. So what does it says? It says that your min half has been empty. Min half should not be empty. So we brought the value from the max half, we inserted in min half, we increase the min half well min half sum, and we erase it from the max half. That is the same logic which we have written over here. And now comes the part, where was it? Okay, yeah. So after this, we have to, in the first iteration only, we have to calculate the sum, means the median, the cost basically. So this will be sum max half minus sum min half plus that median. So for median, let's write another function, calculate median, and a space. So what does this calculate median do? So basically, calculate median is a helper function which calculates the median, and it calculates, basically saying that, now here is something which I think I should explain before moving forward. So we said that when the window size was 3, let's say 2, 3, 4, so median was counted, right, in this portion, which we didn't want it. So we said that 4 minus 2 plus 3, and you have to put the median. So 4 minus 2 plus it should be minus 3 plus 3, and this is going to give us 2. But what if the values are even in the case of this? So the question demands something else from us. It asks for this smaller value. So let's say here window size is 4, and it asks for the median will be 3, right? Because this is the mid value. 3 and 4 both are mid value, but the question demands the lesser value to be the median. Then in this case, if I draw it in number line 2, 3, 4, 5, so everyone has to go over this guy. That means median would be like 9 minus 5 and plus 3. Do we need to do? Let's see. So here we have plus 1, again plus 1, taking the absolute, and here it will be plus 2. So this gets of 4. So that means this addition of median is not required in case of even values, because even though the median is included, there are two medians. So one median which is there, it is going to be balancing that the other median. In other words, when there are two medians, in case of even, we are always taking the lower value. So even though it has been added, we don't need to add it, because as seen in the number line, the difference to reach over here is balanced between the other parts of the number. So that's why we have another function basically to calculate the median, and it says, if let's say window size is even, then we have to simply return 0. Otherwise we have to return min half dot the bigger value in case of odd. That's why we have put over here, and I think the other remains the same, and similarly we have to again print this for this scenario. Or let's try to submit this and see if that works or not. Sliding window cost, I hope I have not done any mistake, and it has been accepted.